This video is about the formation of coat proteins on vesicles that are transported through the endomembrane pathway. When a vesicle containing cargo is exocytosed from a cell, the vesicles surrounding coat proteins can show what organelle it has come from and where it is travelling to. There are three different types of coat proteins that all play different roles in the cell. If a vesicle has been excreted from the ER and is heading to the Golgi, its coat protein will be the COP2 protein complex. If it was travelling from the Golgi back to the ER, or intracellularly inside the Golgi, it would be made of COP1. All of the vesicular movement is then controlled by the final coat protein, clathrin. The main focus of this video is on COP1 and COP2 proteins and their formation. These proteins are made up of various GTPases, receptors and coat-forming proteins that all come together to form the coat protein complex. This complex binds around the exocytosed cargo in a concentrated space to form a rigid supporting structure able to travel its destination inside the cell. Let's look at COP2 formation first. This is a coat protein created when a vesicle is going from the ER to the Golgi in an anterograde or forwards movement. Firstly, a receptor in the ER membrane binds to a piece of cargo. This causes a conformational change in the receptor, making it attractive to the GTPase SAR1. SAR1 is the factor that encourages all of the coat-forming proteins to accumulate together to form the vesicle. SAR1 has an exchange factor, SEC12, that exchanges GDP to GTP, taking SAR1 from an inactive to a bound active state. This conformational change, taking SAR1 from an inactive to an active state, causes it to stick its tail out into the outer membrane of the ER and bind to the receptor attached to the cargo. Next, there are two different types of protein complexes associated with the SAR1 bound protein. Firstly, there's SEC2324, which binds SAR1 and the receptor together. Then there's SEC1331, which multimerizes the SAR1, receptor, and SAR2324 complexes together. SEC1331 causes the accumulation of lots of these proteins so that once the vesicle begins to form, it's on the plasma membrane in a nice, tight, confined space. SEC1331 is also curved, so once the vesicle begins to form, it allows it to round as it leaves the membrane. Once the vesicle buds off from the cell, SAR1 hydrolyzes from GTP back to GDP, becomes inactive, loses its affinity for the vesicle membrane, and floats away. As SAR1 is no longer binding, SEC2324 no longer binds to SEC1331, allowing all of the coat proteins to dissociate, leaving behind only the receptor in the membrane, the cargo bound to the receptor, and some grabs and snares that allow the vesicle to be targeted to the next compartment in the cell. Now let's look at COP1 formation, the transport of vesicles back from the Golgi to the ER in a retrograde or backwards movement. This is very similar to the formation of COP2 vesicles, just with different proteins making up the coat protein complex. COP1 vesicles are formed by certain receptors forming together after recognizing specific motifs, usually at the C terminus of the protein. Proteins with these motifs are either unfolded, misfolded, or proteins that are supposed to be situated within the ER. The most common motif that these receptors will recognize is the K-del motif, which stands for lysine, aspartic acid, glutamic acid, and leucine. These receptors bind to the K-del motif in the Golgi to form a COP1 coated vesicle. COP1 uses different proteins but has the same basic process as the formation of COP2. Firstly, ARF1 is the GTPase that binds to cargo-bound receptor in the Golgi membrane. ARF-GEF is the exchange factor that exchanges ARF1 from a GDPase to a GTPase, causing ARF1's conformational change, allowing it to insert itself in the membrane. This then binds to the receptor, such as the K-del receptor, bound to the ER-bound cargo. This leads to a complex of series complicated proteins that form the COP1 protein coat. Once the vesicle has budded off from the Golgi membrane, ARF1 is hydrolyzed, becomes GDP bound, and dissociates from the cell membrane. As a result, the rest of the protein coat dissociates, leaving behind the receptors, ER-bound proteins, and some RABs and snares. Overall, coat proteins are key in the direction and formation of vesicles within the cell. The different coat proteins are formed under similar conditions, but involve different coat proteins that are key in determining the difference in the destination of the vesicles and the types of cargo they carry. Links to further reading on the formation of these coat proteins will be linked in the further reading section on the ER and Golgi page of our website.